Hello everyone, reporting today for First Updates Now, I'm Abbas, and with me here is Team 16265, Enigma from Albuquerque, New Mexico. They have a fantastic robot this season with a very unique round design that we're going to talk a lot about, and they had the New Mexico State Championship a couple weeks ago, and they're looking forward to the Utah Championship, trying to get one of those very few tickets to the Houston World Championship later in April. Let's dive right into this robot coming up on First Updates Now.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. Kettering University is looking for talented robotics students who want to continue learning and innovating in a hands-on, real-world experience format. Kettering University representatives will be at dozens of FIRST events this season, including the championship. Go to kettering.edu/first to see which events you can meet a Kettering University representative. Check out our all-new FTC content coming to Fun's YouTube, including new hosts from the FTC community. We'll have resource guides, top 10 moments, behind-the-box interviews, and walkthroughs to help your FTC team improve at youtube.com/firstupdatesnow.
Alright guys, let's get started with your drivetrain. Definitely one of the most defining features of your robot with that round design. So we've seen a couple other teams with round robots this year, but I really want to hear how you guys came to this design conclusion and how it's worked out for you so far.
So this year we really wanted to be versatile with our strategy, and so we kind of assumed from the start that we would have a turret design and all of that on there. So to be maneuverable in the field to accommodate for that, we wanted to have a round design to more easily deflect off the poles rather than smashing into them with a more square robot.
Yeah, and so
we found it to be pretty reliable.
Yeah, and so, let's put some numbers to that design. So how many motors are you running, like what style drivetrain, and what are the dimensions, or I guess dimension of your drivetrain?
So our drivetrain is actually pretty small under the skirt here of our round robot. So the drivetrain is 12 by 12 inches. And then the skirt is about 16.4 inches in diameter. We use 7 motors total and about 5 servos.
Got it. And so I see you're running that standard Mecanum drive. We saw some teams go with that X drive. Was there any reason you guys tended towards that standard Mecanum instead?
Mainly experience. Mecanum we found to be very reliable for us in the past. We figured this year it would work well for us again, and we have a lot of experience with it.
Yeah, and so one thing I'm interested in, because I honestly didn't even know you guys had a Mecanum drivetrain under there, is did you ever try your drivetrain just like without the round skirt around it, and you found that you needed the round skirt, or was that just like always from the beginning you wanted to have that round skirt?
So actually with our sister team, we kind of helped to see how a square robot would be in terms of maneuverability in the field, and we found that there was more risk of catching on the poles, and so we kind of knew from the beginning with this robot that we would want that round skirt.
Sure. And so, from a programming perspective, since you do have that Mecanum drive on the bottom, it's fairly standard, I assume. And I see those odometry wheels. So, is there anything you guys want to highlight on the software side about your drivetrain?
So we have used a 3 dead wheel odometry setup. We use Roadrunner to motion profile that and, get all the internals working. And, yeah.
Yeah, I mean, pretty standard, right? Works well. So going on to the rest of your robot, there's so much to talk about here. Let's start with your claw. So just give an overview of how the claw works. We'll talk about, I see some lights there, so I assume you guys have some sensors going on in there, and we'll jump into all of that. So go ahead, please.
Yeah, so we call this a butterfly claw. So basically it's attached to this 4-bar system, and it's on this servo right here, which flips it in, and at the start of teleop, this flips out, and our claw flips. We made it so it wouldn't touch the cones. So when we're going over the cones, it just hovers, so it's not knocking over the cones. And then we use our distance sensor right here, which senses the cones, and as soon as we get close enough, it will grab the cone. And we also have the option for the cone to flip in the robot for maneuverability in the field. And
flipping also gets us an extra degree of freedom.
Yeah. That makes a lot of sense. And so I'm very interested in this wrist pivot you guys have going on. So was that something you added like just from day one of the design, or was that something you realized that you had a need for throughout the season?
So this was a new addition, actually. We found that with this flip-in, there's a lot less bulk hanging out on the field,
Mm-hmm.
again, for maneuverability purposes. And this extra degree of freedom also can help us, kind of line up our cones a lot more accurately.
Yeah, that makes sense. And so after that claw and wrist, do you guys have an additional arm, or is it just straight to the slides?
We have this floor bar right here.
Mm-hmm.
This helps us really for quickness, and we don't have to lift our slides as much,
Mm-hmm.
which is really nice.
And how are you powering it?
It's with one Reefs servo.
Okay.
And we have that on a linkage to one of the bars over here.
Okay, got it. And are you guys doing like any sort of counter springing, or did you just find that you didn't have the need for that?
So that's what these little things right here are for. It's actually surgical tubing that we use to counter spring it.
Okay, so that's
And,
the green like surgical tubing just wrapping around the back.
Exactly.
Okay.
And so the force that's putting on right here is helping counter spring this, because we realized that the servo wasn't quite powerful enough to lift it on its own.
Got it. And so, talking about your four bar, with a turret, I guess there's a much less need to have your four bar go all the way around, which is one of the reasons you guys can go with that traditional four bar design instead of a virtual four bar. So, was there any reason you specifically didn't go for a virtual four bar and have like the arm flip all the way over the robot, or was it just sort of like you didn't need it to?
We didn't really need it to. We figured that our turret could accommodate for that. So we figured with the virtual four bar, a lot of the motion would get pretty complicated, and it wouldn't really mesh well with our entire design.
Yeah, and I really want to talk about that turret, but last topic before we get into that, let's talk about your slides for a little bit. Definitely very fast, very consistent. So what are you guys using for your slides? What's your experience with them, and any advice for teams that are also looking to have like a very reliable slide system?
So we're using two long robotic slides run by two 5.2 to 1 motors. They're located here. Our wires are strung. Our slides are strung continuously, as you can see.
So yeah, we rigged them continuously, and we have a little retraction spool right here, so to help them go down with more ease. And we use 5.2 to 1 motors. We tried to use 13.7 to 1s earlier on, but we figured out that was too slow. And the 5.2 to 1s have been plenty powerful for us.
Yeah, that's fantastic. And so let's jump into that very nice turret. So I see you guys have just pretty much the whole robot base is able to rotate. So walk us through how you do it, how it's so smooth, and any advice you have for teams looking to implement similar systems.
So our turret is mounted on a Lazy Susan, which allows it to run. It has 13.7 ratio for motors, which is 435 rotations per minute. It has a 7 to 1 ratio of belt pulleys, which is every 7 rotations of the turret drive motor to 1 rotation of the turret.
Got it. And so you guys are using just like a large timing belt to power your turret, or how does that look?
So yeah, we have a timing belt that's driving the whole thing. Like she said, our ratio is 7 to 1, so it goes at about 60 RPM at the max speed, which is 1 rotation per second.
Got it.
So it's very quick and efficient. We also have this little brake right here that we'll need to use in autonomous sometimes to kind of help correct a little bit of overshoot, and we found that to be pretty helpful.
Yeah, let's talk about that brake a little bit more. So how does it work, and what exactly? Yeah, how does it work?
So since the skirt is not rotating at all, it's this little piece of surgical tubing that we just kind of have pressed down with this arm right here, and with that force being applied onto the skirt, it kind of helps prevent it to stop it.
Got it. Yeah, and so from a programming perspective, what algorithms are you running on your turret? Is it just a simple run to position is all you needed, or is there more going on behind the scenes?
It's run to position.
Got it, got it. Yeah, Enigma, thank you so much. This has been just a really fantastic interview. You guys did really well in New Mexico. You know, unfortunately unable to take home that winning Alliance cap there in Spire slot, but I'm sure you've been practicing a lot for Utah, going to look really strong for it. So thank you so much for this interview. Really appreciate it. Reporting for First Updates Now, I'm Abbas, and this is Team 16265 Enigma.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. Kettering University is looking for talented robotics students who want to continue learning and innovating in a hands-on, real-world experience format. Kettering University representatives will be at dozens of FIRST events this season, including the championship. Go to kettering.edu/first to see which events you can meet a Kettering University representative. Check out our all-new FTC content coming to Fun's YouTube, including new hosts from the FTC community. We'll have resource guides, top 10 moments, behind-the-box interviews, and walkthroughs to help your FTC team improve at youtube.com/firstupdatesnow. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.